For this lesson, we're going to learn how to factor simple trinomials. So we're going to review what factoring is. We're also going to look at what a simple trinomial is. But to do that, we need to understand how expand and simplify works so that we can actually work backwards, which is what factoring means. So expand and simplify a binomial by binomial. Remember, we did this before. Player 1 on the first team has to multiply both players on the second team. So some of you will write this step in where you say the x has to multiply the x plus 5, and then it's player 2's turn, the plus 3, it's going to multiply the x plus the 5. If you can leave this step out, that's perfectly fine. If you need to put it in, that's okay too. X times x gives you x squared. A plus 5 times the x is plus 5x. Plus 3 times x is plus 3x. And plus 3 times plus 5 is plus 15. Now you have a pair of like terms here. Remember, x squared is not like the x terms because the exponent part has to be the same. So we have our x squared. We have 5x's. We're going to add another 3x's. Altogether, we have 8x's and plus 15. This results in what we call a simple trinomial. It has 3 terms, and it's simple because we have a 1 in front of the x squared. That makes that a simple trinomial. Now, we're going to do the same thing with the other 3 examples. You're going to expand and simplify. So x hops through the bracket, and when it does, it multiplies. Then the minus 7 hops through the bracket, and when it does, it multiplies. Do that for the next 3 examples, and then we're going to look at patterns that we might see here. So put the video on pause, try the next 3 examples, and then you can check your work. Okay, so you should check your work with these. You'll notice every single one of these has a 1 in front of the x squared, which is what makes these a simple trinomial, and it's trinomial because each of the final answers has 3 terms only when you collect your like terms. So a simple trinomial has this format. It has something x squared plus a bx, so something x, and then plus a constant term, and it's simple if that thing in front of the x squared, if the a in front of the x squared is a 1. So these are all examples of simple trinomials. What we want to look at now are patterns. The goal is to be able to go from that simple trinomial format back to this factored form. So that's our goal, is to be able to work backwards here. All right, we know to get a 1x squared, the only way we're getting the 1x squared is from the x times the x. The x times the x is what gives us our 1x squared. We also know that the minus 10 in example C comes from minus 2 times positive 5, or the minus 12 in D comes from minus 3 times minus 4. Except I goofed when I wrote down minus 12 in the answer. That should have been a plus 12. That plus 12 comes from minus 3 times minus 4. The minus 28 here in part B comes from minus 7 times positive 4. So what we're looking for is to go from the simple trinomial to the factored form. We know we're going to have an x multiplying an x to get that x squared, and we need to find 2 numbers that are going to multiply to that final term, that constant term. But the thing is, the 12 could come from 1 times 12, it could come from 2 times 6, or it could come from 3 times 4. We know that minus 3 and minus 4 are the combination that we want to use, but how do we know that? When we are just given the trinomial to work with and we have to work backwards. Well, the minus 3 and the minus 4 are what combine to give us a minus 7. Similarly here with the minus 10. Minus 10 could be a 1 and a 10 times 10. It could be 2 times 5. We know we want to multiply to a minus, so that means one of those two numbers has to be a negative. And because we're adding to a positive, the larger number is going to be positive. So this is our combination right here. So those are patterns we need to notice. So look at the numbers in front of your product or sum when splitting up the middle term. And then look at the constants in the factors of the final answer. So we did that already, sorry. The general rule for factoring our trinomials is this. We're going to find two numbers that are going to multiply to C, but at the same time, those two numbers have to add to the B. If your two numbers are called num1 and num2, like we had a negative 2 and a positive 5, your factors will be x plus num1 and x plus num2. So let's put this into play here. We're going to factor this example. We want to find two numbers that are going to add to the B term, which is negative 10, adds to negative 10, and it has to multiply to positive 21. Since I'm multiplying to a positive, my two numbers have to have the same sign, and because I'm adding to a negative, they're both going to be negative. So I could have negative 1 and negative 21. I could have negative 3 and negative 7. So all I'm doing is listing my factors of 21. And then I check to see, is there a pair that will add to the middle term? So my factored form for this should be x take away 3 multiplying x take away 7. Or it could be x take away 7 multiplying x take away 3. Doesn't matter which of the two factors comes first. All right, so here we are going to factor the following trinomials. Be careful, not all of them are actually simple trinomials. Sometimes we combine types of factoring. Sometimes we need to common factor the trinomial first and then use the simple trinomial factoring if you can. Don't worry about this decomposition, that's going to be in our next lesson. That's not applicable right now. All right, so I've got nothing common between all my values in part A. So I want to look for two numbers that are going to add to positive 7 and multiply to positive 12. So I list out factors of 12, 1 times 12, 2 times 6, 3 times 4. Those are my factors of 12. I'm multiplying to a positive and adding to a positive. So I don't have to worry about making any of my signs negative, and this is the combination that works. So my factors will be x plus 3 and x plus 4. And there we are. If I multiply that out, we're going to get an x squared plus 4x plus 3x, which adds to 7x, and a plus 12. Or you could write it as x plus 4 times x plus 3. That's correct as well. All right, moving on to the next one. We're looking for two numbers that are going to add to the middle term, the b. We're adding to negative 8 and multiplying to positive 16. So when we multiply to a positive, the signs of the numbers have to be the same, and because I'm adding to a negative, they're both going to be negative. I'm going to list my factors of 16. 3 doesn't go in evenly, but I could have a 4 times a 4, and then we're going to make both of those negative, and the pair that adds to negative 8 is this pair here, which then means when I factor this, it'll be x minus 4 times x minus 4, which also could be written as a special product of x minus 4 all to the exponent of 2, because we're really taking x minus 4 and multiplying it by itself. All right, next example. If you want to try the next two examples, C and D, put the video on pause and then you can just fast forward it to the end of those examples to check your work. All right, for the next example, we're adding to 3 and multiplying to a negative 18. That means my two numbers have to have opposite signs to be able to multiply to a negative. One's positive, one's negative. Because I'm adding to a positive, my larger number is going to be the positive one. Now, if you end up doing this and you get the right values except the wrong signs, just switch your signs around and that will work for you. Now the pair that's going to work is the -3 and the +6. So my factors should be p minus 3, and my other factor is going to be p plus 6. All right, next example, I'm looking for two numbers that are going to add to -4 and multiply to -21. 21 could be 1 and 21. 3 and 7. 4 doesn't go in, 5 doesn't go in, 6 doesn't go in. Those are our combinations, multiplying to a negative, but I'm adding to a negative. That means my bigger number has to be negative. Here's my pair right here. That's going to be an x plus 3 and an x minus 7. Or x minus 7 and x plus 3. It does matter that the minus goes with the 7. All right, the next one is not quite the simple trinomial because it doesn't have an x squared here. It's actually an x cubed, but you should notice that every term has an x in common. So we're going to common factor first. We're going to common factor the x out of every term. Minus 2x and a minus 8. So we're common factoring first. Common. Always, always, always common factor first if you can. Always, 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 always common factor first. Always, 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 always common factor first. Okay, now what I have in here is a simple trinomial where I'm looking for two numbers that are going to add to -2 and multiply to -8. So 1 and 8, 2 and 4. Oh, I think that's going to do it. 2 and 4. If I make the 4 negative and I add 2 and -4, I get -2. So my factored form is just going to have the x still copied down there, and then the other part is going to become x plus 2 times an x minus 4. Now the next one, we like to work with an x squared term first. So I'm going to rewrite this in the opposite order. So I'm going to put my x squared first, and then my x term, and then my constant term, and notice the sign in front travels with every one of those terms. Now what I'm going to do is common factor -1, or the negative, out of every term, which just in essence switches every sign in there. So if I expanded that and simplified it, I'd get back to the original expression that we were given. Now we want to find two numbers that are going to add to -4 and multiply to -45. So we could have 1 and 45, 2 doesn't go in, 3 doesn't go in, 4 doesn't go in, but 5 does. 5 and 9 go together. And wait a second, I think if I make the 9 negative here, we end up with a combination here that will work. So now we're going to have negative, we're going to have the x plus 5 and an x minus 9. Now the cool thing about this, the reason we want to do this factoring is so that we know something about the parabola if we're talking about the parabola. For example, I know this parabola is going to open down. We know from the factored form, we know the x-intercepts. The x-intercepts are going to be -5 and +9. So our two x-intercepts then are -5, 0 and 9, 0. So we could do a nice little sketch of that. From the x-intercepts, of course, we should be able to get the coordinates of the vertex by finding the midpoint of those two x-intercepts and then dividing by 2. So hopefully so far this makes sense. I do have another couple of examples here. So let's try and fit these two examples in. The next example, we also want to look for a common factor first. 4 will divide every single one of those terms, so I'm going to divide 4 out. Leaves me with a simple trinomial in here, and I would be looking for two numbers that are going to add to 2 and multiply to -8. And I believe, I can list out my factors 1 and 8, but I believe -2 and +4 will work. So my factored form then will be 4 bracket x take away 2 and then an x plus 4. This last example is very similar. The thing that throws people off are these y's. Let's pretend the y's aren't even there, but treat the question exactly the same as the previous ones. I want to look for two numbers that are going to add to +3 and multiply to -18. So 1 and 18, 1 and 18, 2 and 9, 3 and 6. It's good if you've got good number facts. My two numbers have to be opposite signs. My bigger one's going to be the positive. Out of this pair, here's the one that works. Everything here is almost the same. We're going to have x times an x to get the x squared. We're going to have a minus 3 and a plus 6. But to get those y and y squareds, I'm just going to put the y's with that. If you expand and simplify, you'll notice you get what's there as the original question.